Welcome friends. Today we are going to solve another problem from the book of topics in algebra, problem number 16, and it is from the subgroup chapter. So in this problem it is given that H is a subgroup of a group G, and let NH is equal to G belongs to G such that GHG inverse is equal to H. We need to show that NH is a subgroup of G, and then we will show that H is a normal subgroup of NH. So first try to solve this. Okay, uh, whenever we need to show that a particular group is a subgroup of some other group, then we need to take two element from that group. That means A and B belongs to NH, and we will show that AB belongs to NH and A inverse belongs to NH. That means if A belongs to NH, then A inverse also belongs to NH. If we can show that, then we can prove this, the first part. NH is a subgroup of G. So let's start with this. Let's take two elements P and Q. Okay, sorry. P and Q belongs to this NH. This implies that P and Q will follow this, that PH P inverse is equal to H, and QH Q inverse is also H. Why? Because this P and Q are element from this NH. If P belongs to G, then PH P inverse will be H. This is what we followed, and we get this thing. Now we need to show that PQ belongs to NH. If we can show that, then the first part will be done. So PQ H PQ inverse. We need to show this is equal to H. How we will show that? PQ H Q inverse P inverse. Just rewriting this part. Now QH Q inverse. This is equal to H. So P H P inverse. Just putting the value here. From here I am putting the value here. So PH P inverse, and this PH P inverse is equal to H. This implies that PQ belongs to NH. This is the first thing. Next, now we need to show that if P belongs to NH, then P inverse will also belongs to NH. Since P belongs to NH, we have PH P inverse is equal to H. Now P inverse H, sorry, okay, no, it is okay. P inverse H, P inverse inverse. We need to show that this is equal to H. If we can show that, then we are done. So P inverse, for this H we will put the value, because H is equal to PH P inverse. So put the value here, PH P inverse, and P inverse of P inverse is nothing but P. This implies P inverse P H P inverse P. This is the identity, this is the identity, so that will be H. So P inverse also belongs to this NH. This implies that NH is a subgroup of G. Let me write that NH is a subgroup of G. Okay. So now return back to the second part. Okay, now let's solve the next part, where we need to show that H is a normal subgroup of NH. Let us see how to solve this. So what we did, we take an element H belongs to H, and since this H is a subgroup of G, then H inverse will be H. And that means if you look at the NH group, if an element belongs to this NH, that will follow this property, and this H is following the same property, H inverse is equal to H. This shows that we take an element H from the group H. This shows that the H also belongs to NH. That means this group is a subset of this NH, and this NH is a subset of the big group G. Now NH is a subgroup of G and H is a subgroup of G. This implies that H is a subgroup of NH. Okay, but we are not done yet. We only showed that H is a subgroup of NH. We need to show that H is a normal subgroup of NH. Okay, let's go to the next part. Now, if we take any X belongs to NH, we need to show that X inverse, that also belongs to NH. If we can show that, then from the definition, H is a normal subgroup of G. So if we take an element X belongs to NH, from the definition of NH, X inverse is equal to H. And since X inverse is equal to H for every X belongs to NH, this implies that H is a normal subgroup of NH. So what we did, let me repeat this. First, we took an element from H and we showed that this H also belongs to NH. That means H is a subset of NH, and from that this is subset of G, and NH is a subgroup of G, H is a subgroup of G. This implies H is a subgroup of NH. Now we are left with the normal part, and we need to show that X inverse belongs to NH. And so what we did, we take an element X from NH, then X inverse is equal to H, and X inverse is equal to H for every X belongs to NH. From that we get that H is a normal subgroup of NH. So the problem is proved. I hope that you understand the problem. If you have any doubt, then please comment. And thanks for watching. You can also suggest me any problem anytime. And thanks for watching. Thank you.